Okay, so now we're going to talk about some other characteristics of these functions. There's something known as a period, okay? And these functions, sine and cosine, are known as periodic functions. And what I mean by that, so I'm going to pull up this unit circle again. I'm going to make it really big. And hopefully you get in the habit of, I know we don't all have a printer, but having that unit circle out so it's just really easy to use throughout this entire unit. All right, so if I'm just looking at sine, I'm going to look at my y's, okay? So I have here 1/2, or let me start here. I have 0, it goes to 1/2, root 2 over 2, then root 3 over 2, then 1, then a positive root 3 over 2, root 2 over 2, 1/2, 0. And we keep going on. Now, you might say, like, wait a minute. Okay, let me back up. You have here, we're looking at just sines, so that's why I'm only looking at the y values. We're looking at when it starts to repeat itself. So some of us might look and be like, okay, well, it repeats itself right there. We're done. But we got to get all the way through the negatives, and we have to get through that -1. And then we got to get through these negatives as well, but then we got to get here. So really what happens is how long it takes to repeat itself, and that's what it means to be a periodic function, okay? It means that a function starts to repeat itself, is every time I go around this circle, it starts to repeat itself. So remember that around the circle once is 2 pi. And so what that means is, get rid of this guy. It means that our period for sine is 2 pi, and it says and degrees, so I'm going to put 360 degrees. Every time I go around that circle, it starts to repeat itself. And that's really important to know because I can use that information to evaluate and make my life much easier. The same would go for cosine. It repeats itself every 2 pi and 360 degrees. So I'm going to go back and show this unit circle again, just to convince you of cosine. It's going to be the same rationale as sine. I'm just going to look now at my x's. Okay, I hit a 1, I hit a root 3 over 2, I hit a root 2 over 2, 1/2, I hit a 0. I hit the negatives, great. I hit the -1. Then I hit the negatives again, then I hit 0, and then I hit the positives. Well, the only way I'm going to get out those same exact values is if I go around the circle again, and again, and again. So every 2 pi units, I'm going to get the same thing, and so that is known as its period. For tangent, it's a little different. Tangent, remember, our definition is y divided by x. So tangent for this one is 0. I'm going to do these quickly just to save us some time. If I did tangent of pi over 6, remember it's this thing divided by this thing. That would give me root 3 over 3. Tangent for this guy is 1. Tangent for this thing is root 3. Then I get undefined because 1 divided by 0 doesn't work. Again, I'm just going to go through these quickly to save us some time. I get negative root 3 here. I get -1. I get negative root 3 over 3. So I haven't repeated yet, right? Here I get 0. And then I start doing it all over again. Now I'm going to get positive, because it's a negative divided by a negative, root 3 over 3, positive 1, positive root 3. Oh, I get undefined again. Here I end up getting negative root 3. This is going to be -1, and this is negative root 3 over 3. Well, remember, the idea is when does it start to repeat itself? So when can I get all the same values that I already got? Well, here I got a 0. I get this stuff, this stuff, this stuff, undefined. Here I get all my negatives. Here I get my 0 again. And then look, we start getting all those same exact things one more time. So really, my period for tangent is just pi. We don't have to go around the whole circle to get it. So this is going to be 2 pi or 360. For cosine, it's also 2 pi. And then for tangent, it's special. It's going to be pi. And so what this is saying is, if we add the period, it won't affect our answer because it just repeats itself. This is some other functions. We don't use that often, but because the reciprocal of sine is cosecant, that's the same, it gets the same period. Secant gets the same period as cosine, and cotangent gets the same period as tangent. But really, we just focus on those three. And so how we would use this to help us is sine of 390 degrees. One way to do this is visually. So I'm going to go ahead and get this much cleaner for us quickly. Now, 390 degrees. So that means I go around the circle one time, right? That's 360. And how much more do we need? Well, we need 30 more. So I go around once, and then I go an additional, and I stop. What is sine here? That's going to be 1/2. Algebraically, and you could just do that. You don't have to show your work, but it is nice to show your work in case you get it wrong, so then I can figure out what happened. What you did is you did 360 degrees. You did 360 degrees and you added the 30. Well, what this thing is saying up here is you don't have to think about the period. You can just find sine of 30. And you'll get the same thing because it starts to repeat itself. So for this one, cosine of 17 pi over 4. These are ones that typically students struggle with because they're fractions. And how I want you to break this up is how many times we're going to write that improper fraction as a mixed fraction. So again, some algebra skills that might be lurking behind you. How many times does 4 go into 17 pi? Well, 4 goes into 17 a full 4 times. And how many do you have left over? Well, 4 times 4 is 16, so you have 1 left over. Okay, so really, this is telling me I have my period 2 times, because my period is 2 pi. So if I have 4 pi, that means I doubled it. And if you're getting it, you can ignore it and just find sine of pi over 4. Cosine of pi over 4, which is root 2 over 2. If it's still a little funky, and we're going to do more together as a class, but if it's still a little funky, what we're doing here is we go around the circle 4 pi. So, whoops, 1 time is 2 pi. Then I go around again, that's 4 pi. Now I need an additional pi over 4. So I'm right here, and that's how I got pi over 2. Root 2 over 2. Again, we're going to do a lot of these together. Secant of 420 degrees. Well, I can break that up to be 360. And then what's the leftover? 60. So what that's saying is I can ignore my period because it just repeats itself. It wouldn't affect my answer. And actually, if you look on your unit circle, secant is the reciprocal for cosine. So I'm going to look at my unit circle where cosine is 60, and that is 1/2, but I want the reciprocal, so the reciprocal of 1/2 is 2 over 1. And we're going to do a lot of these together, one more again, okay?